Well, we can never really use standard form, right? Sorry about that. Well, it's not an exponential function, but y'all, what are the three forms or approaches we can use to solve a quadratic equation? Vertex, quadratic formula, and what did you say is the middle one? Factored form. What is the only one I cannot use on these three equations? I cannot use factored. You can always use the quadratic formula. As long as you have a good vertex, you can use the vertex form, but you cannot use factored form unless you have what? X-intercepts. What do I not have? X-intercepts. You need to recognize that, hey, if I don't have the x-intercepts, I can't use the factored form, so I'm not going to use that form. I'm going to use vertex form, I'm going to use the quadratic formula. But this also should inform us, and this is what we made a note of on number 2. What do we know about the solutions? They have to be what? They have to be imaginary numbers, right? Those are things we want to notice. Also, don't forget, I'm not going to call it a solution. I'm calling it either roots or zeros. Once you get to 0 equals something, then you can call it a solution. I do want you to make this note on, hopefully this page or somewhere in your textbook so you can use this to study later. Because in checking and grading the homework, I noticed something that I do not want you to do. When I ask you for x-intercepts, I want you to write your solutions as points, r1, 0, and r2, 0, right? X-intercepts are points, because it's an x and a y. However, if I ask you for the roots, or I ask you for the zeros, what I am asking you to do is I am asking you to write it as x equals r1 and x equals r2, right? If I am asking you for the x-intercepts, write it as the point, x comma y, right? r1 comma 0 and r2 comma 0. But if I'm asking for the roots or the zeros, I want x equals this thing. We good on that detail? Jay, do you have that in your textbook so you can use it to study later and make sure you get that detail correct? It really must be a hassle to take 20 seconds to write down those notes. Yes, sir.
You have the textbook, pick up this packet.
You like the backpack?
Yeah.
I have one that you can take, you can have open, but you can't write in because this will be a textbook for a student next semester. So you need some paper and something to write with it too as well. I would be willing to bet.
Yeah.
Okay. We have a pencil there. You want to sharpen that quickly? By the way, I know I haven't done a good job of showing this, and I should have pointed this out before. Can I get everyone to hold your spot on M1- whatever, but go to M1-115 really quickly. What is at the end of each lesson? A summary. If you flip through there, right? We see a summary of each lesson and what you should have learned from those lessons. So at the end of the unit, you will see these summaries every time. That might be something helpful to study, right? A summary of all those big ideas. Notice we did not do every lesson out of this unit, so you don't need to look at every lesson, but it would be really helpful to look through those. That's also kind of the point of the graphic organizers, to summarize all the information we've looked at. Any questions? Good? Okay. And so this is where we ended, I believe, in number 4, right? How can you use the structure of the function to determine whether its zeros are real or imaginary? What did I tell you about 4a? Yes, ma'am. Okay. What did I tell you all about 4a? Did you write anything down? You don't have anything written down because I told you all not to worry about it, because I don't stress about using the structure. How could you figure out really quickly whether the zeros are real or imaginary? Graph it, right? If it doesn't touch the x-axis, you've got imaginary roots. If it does touch the x-axis, or intersect the x-axis, you have real roots, okay? Did we finish 4B in class? Yes? Okay. This is actually no, I don't want to say that, never mind. So then we did not get to number 5, did we? No. Alright, so I want you to work within your small groups. It shouldn't take long to do part A. Once you get done with part A, move on to B, C, and D. We will come back once it looks like everyone's finished C and have a whole class discussion. But I want you to tackle this number 5 in your small groups to get practice with this. We'll get some more practice moving forward, and then we will take our understanding check. Any questions? Okay, we know what we're supposed to be doing? Huh? Yeah, let's get to work. We literally just, I think we just worked on this, didn't we? Did we finish anything with the complex numbers? Yeah. We did, we did 6.2, so like you should have already had notes. Well, you have notes on the very first page of it, right here, but then we also finished, we did all of this. Learning how to, well, it honestly wasn't terrible. This part people did not like, but these two were really easy, just determining which number sets, or which sets each number went into. But even this isn't terrible. The video is already up. Are you allowed to watch videos? No? Don't watch the video then, I lied. So, here, come back here and I'll talk with you about this for a second, and then